Hi guys, in the class we discussed about finding the network using two methods, and the first method was using a like each force and finding the individual work done, like WF1 in this case and WF2 here and WF3. So pause the video first and then read the problem, and then we can start again. The second method that I discussed was W net equals F net dotting to displacement. And when you read the problem, you can see that F1 is given 3 newtons, F2 is given 4 newtons, and F3 is given 10 newtons. And also we have the theta 3 given as 35 and theta 2 given as 50 over here. So we got all those things. However, we don't know what direction that it is moving. It says, the question asks us, what is the net work done on the canister by 3 forces during the first 4 meter of displacement? But we don't know the direction. In the class when we were doing that randomly chosen example, I picked the direction to be forward, but in a book problem you can't do that. So the first method is not quite the way to handle this one. So you can't use the first method, and we are going to use the second method and do the problem. When you are using the second method, the direction of F net should be the direction of the motion of the block. So here F net dotted to D, and that would be, if you draw the picture, here is the canister and F net is pointed in this direction. If it is the case, then the displacement direction also should be in the same way. Now with that in mind, let's find the net force. Now I am not going to do this entire problem for you guys. So I am going to do it halfway, and you are going to complete the problem and submit it on Blackboard. And I am using these credits to replace the lowest quiz grade. So finding F net. So first thing first, we are going to bring the canister down to a dot, and then we mark the forces. First force, according to the picture, F3, and there you have 35-degree angle, and the next force is F1, and the last one is F2. And the F2 force has an angle given to us, and it is not really typical, but this is given as 50 degrees with the negative y-axis. Now you all know how to find the F net. In order to find F net, you have to get the sum of Fx, and then you need to square that, and then you have to take sum of Fy, and then you need to square that as well, and then add them, and this is how you find F net. In order to find F net, so let's find Fx and Fy. So here we got F1x and F2x, and there you have F3x. So F1x, the angle is cosine 180. F2x, the angle is cosine 210. F3x, the angle is 35. Now F1 is given to us, F2 is given to us, F3 is given to us, and this is our X table. So you guys can go ahead and find what you get in each of these columns and put the numerical value, and you can add all of them together, and this is how you find sum of Fx. So pause the video and do that part. And then here you have the y table. This is y, and you got the same exact form except cosine is replaced by sine now. So you got f1y, f2y and f3y, and there you have f1 sine 180, f2 sine 210 and f3 sine 35. And then once again substitute for f1, f2, f3 and then multiply that by each of the sine values that you get, and then you can sum it up, and this is where you get sum of fy. Once you get the values for the net x over here and net y over there, then you can substitute or both of those in the equation to find f net. So the f net is going to be this sum of fx as we said earlier, and then you have fy, sum of fy square. So that's how you find f net. So pause the video and complete that step and write down what you get for f net. Once you have that, then we are ready to find the network. So the network is given by f net dotted to D. Now as I said, the direction of the canister's motion would be the same direction as the net force. Therefore you can say that these two vectors are parallel. So the angle cosine theta in this case is going to be cosine 0. So substitute for f net, substitute for D and substitute for theta as 0. And now you are ready to get W net. So please complete this and take a picture and post it on Blackboard. And that will replace your one of the lowest quiz grades, and please work alone on this one.